Good morning, good afternoon, good evening. Whenever you are watching this video, let me welcome you all to our channel Future Endeavors. Okay, so in the previous class we have discussed about the velocity time graph. Today we are going to discuss about the acceleration time graph. Okay, so it's quite similar to the what we have discussed for the previous two graphs, that is for displacement time graph and velocity time graph. Okay, so here the only changes that you need to see is in the x-axis we will be plotting time as usual as in the two previous cases. However, in the y-axis we will be plotting the acceleration. In displacement time graph, what we have plotted in the y-axis, we have plotted the displacement, whereas in velocity time graph, what we have plotted the velocity. So these are minute changes that you need to keep in mind while practicing these graphs. Okay. So coming to acceleration time graph. Okay, acceleration time graph. Okay, so for acceleration time graph, we will be getting some similar figures as we have obtained in velocity time graph or displacement time graph. Okay, so first of all, we are going to consider if the acceleration of a body is uniform. Okay, if the acceleration of a body is uniform. So for uniform acceleration, what will be the graph like? Uniform acceleration. So for uniform acceleration, I think the graph should be something like this. Okay, if I just consider this is the x-axis, that is the acceleration axis. Okay, and this is the y-axis, that is the time axis. Fine. Now, if I am considering constant acceleration or uniform acceleration, then obviously the graph will be something like this: a straight line parallel to x-axis, that is parallel to the time axis, isn't it? Because with changing time, the acceleration remains same. So acceleration will be having the same value with changing time. So this is the acceleration time graph for a constant body having a constant acceleration. Okay. Now, if you consider the velocity time graph corresponding to this kind of uniformly accelerated motion, so can you imagine what will be the velocity time graph for this kind of graphs? Obviously, I think you can guess. Since it is having a uniform acceleration, what does that mean? That means that the velocity of the body is increasing uniformly with time. Say a body is having an acceleration, constant acceleration of 2 meter per second square. Okay. Now, what does this statement mean? It means that each second the velocity of the body increases by 2 meter per second. So if we start from 0 at time t equals to 0, what happens? After 1 second the velocity will be 2 meter per second. After 2 seconds it will be 4 meter per second. Then again after 3 seconds it will be 6 meter per second. Then after 4 seconds actually it should be at 4 seconds. At 4th second it will be 8 meter per second. At 10th second, at 5th second it will be 10 meter per second. So like this the velocity keeps on increasing for each second that we add on. Okay, so this is the entire concept. So if you actually plot this kind of motion in the velocity time graph, okay, then I think you can understand that the velocity time graph will look similar something like this. Okay, you can draw this on the right side of the board. Okay, I am drawing it a little smaller. Okay, so the velocity time graph would be something like this. Velocity time graph, the velocity constantly increases, so the graph will be something like this. If we start from 0, it will be constantly increasing. Okay, so this is the velocity time graph for uniformly accelerated motion, or you can say that the corresponding to the acceleration time graph of the nature shown in on the left side, the velocity time graph will be something as shown on the right side of the board, isn't it? Okay. Next that we want to discuss is that if the acceleration is increasing, okay, if the body is accelerating and the acceleration is now increasing, means initially say the body is having an acceleration of 2 meter per second square, and then after some time the acceleration is 3 meter per second square, then after some time it's 4 meter per second square. Now if this change is uniform, the change can be uniform as well as non-uniform. If this change is uniform, that means the acceleration is increasing linearly. Okay, the acceleration is going up linearly. So if I say that the acceleration is constantly increasing, then what will be the nature of the graph? Okay, if the acceleration is not uniform, it's increasing acceleration. Okay, increasing acceleration increasing acceleration, but that increases in a constant way. So increasing acceleration, okay, increasing acceleration, but the increase in acceleration, okay, or the acceleration that is increasing is in a linear fashion, is uniformly increasing. Okay, so it's uniformly increasing but uniformly increasing. Previous case was it was a constant. Okay, it was a constant, but here if it is uniformly increasing, what does the graph look like? Okay, obviously I think all of you have already guessed what will be the nature of the graph, acceleration versus time. So it will be just like this, a straight line passing through the origin. If you consider that the acceleration at t equals to 0, we have seen that the acceleration was 0, then it will be something a straight line like this. Okay, fine. So this is the acceleration time graph for a body for which the acceleration is increasing, okay, each moment. Fine. Now can you guess what will be the velocity time graph for this corresponding acceleration time graph? The velocity time graph for this corresponding acceleration time graph, can you imagine what will be the nature of the velocity time graph? Can you imagine? For this, the velocity time graph would be something like this. Many of you, I think, have been able to guess, okay, and many of you will be also correct. Still, just to verify your guessing, okay, so I am showing it. It will be increasing. Now it will be increasing like this. Okay, initially when the acceleration was not so much, the increasing velocity was not so high. Okay, for a small change in time, the velocity change was small, increase was so small. But as the acceleration keeps on increasing, what do you do? As the acceleration keeps on increasing, the velocity after some time is increasing at a faster rate than it was initially. Okay, so this is why the graph for the velocity time will be something like this. Okay, for an increasing acceleration graph. Okay, fine. Okay, now so I think the concept is clear. Now just let us move on to the next case, that if the acceleration is not increasing uniformly, rather say the acceleration is also increasing but non uniformly. Say initially for 0 seconds it was 0 meter per second square, then after 1 second it becomes 5 meter per second square, then after 2 seconds, when at 2 seconds it suddenly becomes 12 meter per second square, then after at 3 seconds it suddenly becomes 30 meter per second square. So the acceleration is increasing and it's a non-linear fashion, it's non-uniformly increasing but non-uniformly. Okay, then what happens? I think you are able to guess. Okay, the graph would be something like this. Okay, the graph would be something like this. It goes on increasing. Okay, but the increase is after with increasing time, the rate of increase also becomes more. So definitely it will be something like this. And for this kind of graph, acceleration time graph, the velocity time graph can also be predicted, but I will leave that question for you to answer, or to just think of that what could be the possible nature or the shape of the curve for the velocity time graph in such cases. Okay, fine. Now these are the acceleration time graph that you need to understand for a motion in one dimension. Now if you consider the motion under gravity, okay, if you consider the motion under gravity, so it's a special case. So just let me show motion under gravity. So we will be just discussing the three kinds of graphs for motion under gravity. Okay, so just let me discuss for the motion under gravity case. Okay, so it's motion under gravity. Okay, motion under gravity. Fine. Okay. So if you consider the motion under gravity, now when, as you know that Earth is attracting all objects with a certain force, and for that actually each falling object is having certain kind of acceleration, and that acceleration is called the acceleration due to gravity, or we can also say gravitational acceleration, whose value is approximately about 9.8 meter per second square. In some cases we consider it to be 10 meter per second square. So basically what we are considering, we are saying that when a body is under the gravity, is in motion, so it's basically a case of motion under uniform acceleration, uniformly increasing acceleration. So this is the case of motion of a body, okay, under uniform, or you can also say constant acceleration. Okay. Okay, so this is the case. Now for this, obviously the the acceleration time graph would be something like this. The acceleration time graph would be something like this. The acceleration time graph would be just a linear graph which is passing through the origin, so it will be something like this. Okay. Now when we are saying that the motion is under the constant acceleration, obviously its velocity keeps on increasing for each increasing second, and for that what happens, if you consider the velocity time graph, okay, if you consider the velocity time graph, is just basically keeps on increasing. The velocity, what happens? Oh sorry, it's constant acceleration. Sorry for the mistake. Okay, for constant acceleration the graph would be something like this, because the acceleration is not increasing, the acceleration is constant, isn't it? Now for this constant acceleration, what happens? The velocity keeps on increasing. Okay, the velocity, actually when a body falls freely under the force of gravity, or say from a certain height a body is falling freely, what happens is velocity keeps on increasing. Okay, so for that the velocity keeps on increasing, then the graph would be something like this for the velocity time graph. Okay, it will be something like this. Is it true or not? I think all of you have understood the mistake, that this should be not like this, because the acceleration is constant. Then why should the velocity time graph increase like this? It will be increasing linearly. So the velocity time graph will be something like this, isn't it? So I think just seeing the velocity time graph, many of you should have, I think you have also reacted that no sir, it is wrong. Actually this should be like this, isn't it? Okay, and the corresponding displacement time graph, what will be the value, what will be the nature of the displacement time graph? Now this displacement time graph, S versus T, this will be something which is like this, non-linear in nature, because with increasing seconds, actually the velocity, when the velocity increases, definitely the displacement will become more within a certain span of time, isn't it? For the same time interval, when the velocity increases, for the same time interval, when the velocity increases, definitely the body will be traveling with a greater displacement, isn't it? Okay, so it will be something like this. Okay, so I think the concept of motion under gravity is also clear. Okay, so with this we come to the end of this part of the chapter. In the next class we will be discussing some numerical problems related to the motion in straight line. Okay, and there are some formulas which will be discussed. Okay, those are called the equations of motions, and we will be dealing with some numerical problems. Okay, so with that we will be ending our class here today. In the next class we will be moving on to the next part, that is the equations of motions actually, and we will be discussing some numerical problems related to those parts. Okay, so till then please do study well, and if you have any query, any question in your mind related to these topics, please do mention it in the comment box. We will be happy to solve your problem. Till then please do study well. Goodbye. Thank you.